Hello there, students. Welcome back. You have gone through Excel, and considering there's no access this time around, because we're doing this online, it has been replaced with C++. And if by any chance there was a version of this class where you're watching it with access and C++, well, then that intro doesn't make any sense. So anyway, we're going to go to jdoodle.com. So www.jdoodle.com. And there's plenty of different things to pick from. If you've taken me for CSC152, you know that we would go into Python 3. But for this class, we're going to go into C++ instead, because that's part of the curriculum. So we're just going to click C++. So this is what JDoodle looks like. I highly recommend you make an account, because then you can just go over into these little dots right here. A little menu will appear and you can save the file, and then you can have all these different files all under your account, so you never lose them in case you have to move to another computer or your computer breaks or something like that. It's all cloud-based. So I highly recommend you do that so that you keep your previous codes as reference for your big codes. Now, so here's what it looks like. Up here is where you would type your code, okay? You're typing your code, and then you're going to hit this execute button, and the code will appear down here in this black area. And of course, if you have any inputs, you can put it in there, or you can type in the interactive button. So if you have anything where you need to type in an answer, you would just use that interactive button. And that's basically how this website will work. So we're going to start off with, let me just go and get myself my little cheat sheet ready. I've got some Xcode up here, and I'm going to just use that just to make sure that I don't make any errors. However, if I do make any errors, I will also be making some intentionally just to show you what they look like. So let's just go in and let's go in here. So the first thing probably you're going to want to do is you're probably going to want to delete everything. Now, here's my thing that I would like to mention to you. Don't delete the using namespace std. Don't delete the include IOStream. Don't delete main, and don't delete this guy back here, this little thing. So there are specific reasons for it. For example, if I delete this remove namespace, this cout is not going to work. It's going to give me an error. It says, linked to standard output. But what are we using? Well, we do have the input-output stream, but that std thing, using namespace std, that means standard. That is the standard thing. So if you were to somehow delete that, what you would have to do is you would have to keep every single time you have a cout, you're going to need to do std : to fix that error, to let it know that it's a standard. That it's using the standard output. Okay? So, and that's what, honestly, all of my code does. Every single time I use a std for a string or a cout or anything like that, or a cin or a character, I do that because I'm just in the habit of doing that. But for the sake of not having to type std : every single time, just make sure you include that using namespace std, and let's just always include the input-output stream, because if we delete that, it doesn't understand how to input and output it. Think of coding like a car. And inside your car, you need things like an engine, or a battery, or, an alternator, or a radiator. And, basically, there are certain parts that you're going to need before you even start coding. So just delete the stuff that's in between the main and the main. So whatever you start, you must end. So this little squiggly bracket right there means that that's the start of whatever int main is. And that little squiggly bracket means it's the end of whatever squint main is. So if you don't have this and you don't have that, it's going to be an error. It's not going to help you out there. It's going to go and say, hey, something I don't understand. Now, the reason why I do like Xcode is because it will tell me in real time if I screw up. So if I were to do something and not have this STD here because, I don't use it, it'll flat out, when I try to go into mini project 1.1, yeah, see, there we go. It's going to tell me right there on this line, hey, wait a minute, use of undefined something something. It's going to tell me right there, use of undefined identifier C out. Do you mean STD : C out? Well, yes, I do mean STD : C out. And most every single, coding program that you can download will do stuff like that. This is just a free one online, so it'll kind of tell you what line you're in the error when it's in the results, but it's not going to recognize that there's results until you hit execute. So, don't worry. So, well, the first thing we're going to do is, let's just put our name on it. So if I were to just say, like, hi, my name is David Monticchio, and I try to execute this, first thing it's going to do is it's going to go and say, sorry, there's an error. I don't understand what David is. It thinks I'm trying to declare something. So there are certain things that you can do in coding called commenting. Commenting is simply in this language, //. And now you see how that text turned green? Sorry for anyone that's colorblind and can't see it. But what that means is that text is now invisible to the computer. It will read it line 1, line 2, line 3, line 4, line 5, line 6. Oh, line 7 is invisible. Line 8, line 9, line 10, line 11, line 12. So, now when I execute it, there's essentially nothing happening, so it executes in like 1 second, and there's nothing that's an output. But it skipped over it. So you can use comments for little notes to ourselves. So if we need to make a note to ourselves and say, hey, wait a minute, this is the input-output stream, just for people to know this. And in this right here, this is the standard, set, of the standard namespace, actually. I should say namespace. Use the correct terminology, David. These are little things to help. So what could you do this with? You could do this like where you say, like, okay, you can build stuff out like, this is where I'm going to loop the turn order, or whatever, whatever it is, just to let people know what it is you're going to do. Because, once code hits, 100 lines, 200 lines, 300 lines, eventually it's going to get hard to find stuff. So you probably want to leave little notes to yourself, leave little comments so that you can find what it is you're looking for. Okay? So like that. So anyway, we have ourselves int main. So here's the first thing we're going to do, is we're just going to say, C out, caret, and notice the carets are pointing to the left. And then we're going to put quotation marks, welcome to the output program. And then we're going to end the line with a semicolon. You will need to end every line with a semicolon, basically. That is how the computer knows, hey, this line has ended. And let me just capitalize P in program. So now when I execute it, it says, welcome to the output program. So what does cout mean? Cout stands for computer output. Computer output is stuff that's, outputting to the player. So it's stuff that you will see. The person inside is going to see it. So, that's basically everything that we're going to be doing thus far. As the first thing you're going to do is, welcome, hello world, that sort of thing. So, there are certain things we can do here. We can also do, /n/n. Now, /n means new line. So, if I were to put some stuff after it, execute, you'll notice that now there's new stuff after it, and it dropped down 1 line, 2 line. Okay? You can also, if you want, have /tab. And then I'll, say, and then we can have the gibberish. That /t is a tab. See how it made a tab there? So I have new line, tab. So it went new line, new line, tab. So that's the sort of stuff you can do in this sort of program. I'm just going to keep the new line here, just because, and that's, the \n, those are the frequencies for new lines. Those are stuff that is that. So now, why is this in quotation marks right here? Well, what those quotation marks are is they are a string. If I get rid of those quotation marks, it does not read it as a string. Now, a string is just a series of characters. It can be numbers, it can be letters, it can be symbols, and it just says, a string is something that can get shown out. It's a type of object. There are many different types of objects in C++ coding. A string is one of them. A string is just a series of text that gets printed out. It's like a text message. So, if we want to remember this, this is a string, okay? And much like how this needs a start point and an end point, you start it with one quotation mark, with one double quote, you end it with another double quote, okay? I'm just making sure you need to remember that, okay? Also remember, you need to have that little line at the little semicolon at the end of everything. So, let's, and we could start doing that all the time. We could keep doing, we can do another, C out, blah, 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 blah. And we could keep doing that over and over again. We could keep making more C outs and C outs and C outs. But we're not going to just do just that. Okay? Because in all of this, there is also types of data. Okay? Because I've already started it. I've already started using a string. So how about we go over the 5 different types of data that we can use here, okay? There's 5 types that are going to be the most common. So I'm going to start with declaring something, an int. And I'll just name this example integer equals, and I'll just say it's 10. So what is an integer? An integer is a whole number. So 10 is a whole number. If I were to do, 10.8, 10.8 is not a whole number. An integer cannot do decimal points. Okay? So, if you always want to remember it, ints are whole numbers. Okay? Int are whole numbers. Okay? So, that's always a good thing to remember. And if you want to float, well, I'll just make an example float. And I'll just make this, 5.5. So, if you can know what a float is, obviously, it's another type of number, but it's one that includes decimals. This is a floating point number. That point right there, and it's floating, you can go out anywhere. So basically, floats include decimals. So, of course, I can just, make something a string, and I'll name this example string, and it'll make it say hello world. Okay? So, and we've already used string, but string are, they are sets of characters. They are sets of characters. Characters can be, letters, symbols, numbers, okay? So they are just stuff you type, and I'm just tapping these guys over just so it looks prettier and you can see it all. Oh, now why did string decide it doesn't want to turn purple? Let's see if that gives me an error here for a moment. Nope, okay, we're good. So it still works, it's just the word string decides it doesn't want to turn purple. Okay, I bet you char is going to do the same thing then, so let's try char. Oh no, char turned purple. Did string turn like a different... No, string is just still black. Okay, well, you know what? Example, char. And I'll just say equals, and I'll just put a single quote here, W. Yes, you need a single quote, not a double quote for chars. And chars are simply single characters. So, one char is not a string. But if you have multiple chars in a row, they will make a string. Okay? And then I will just say bool, example, bool equals, and I'll just say it's true. So, bool is only true or false. So remember when I went back and said the pyramid of coding, where that bottom layer, at the lowest coding, the computer really only understands on and off, true or false, yes or no? Yeah, it's still in there. A bool is either true or false, yes or no, on or off. Okay? And the words you're looking for are either true or false. So, what are all these guys? Because you see how I have like this word example integer, example float, which I put an n at by mistake, example string, example char. These are all variables, okay? And you can type whatever it is you want as a variable as long as it's one word. The minute I put a space in there, it's going to cause an error. And it will execute at some point. Yeah, see, example char, you know, it says error, expecting initialize before char. So, basically, the moment you put a space in there, it's not going to work. But this time, I'll put it in there and it will work. So, what exactly are variables? Variables are basically buckets. They are containers. They are drawers in a chest. Any sort of visual metaphor you can think of. They are stuff that you put things into. Okay? So basically, when I said int example integer equals 10, I am saying, hey, somewhere in my memory, I want you to save a space for me. The name of that space is example integer. What I'm saving is an integer type, and what's going in there, I'm putting a 10 in there. Okay? So I want you to save that 10, put it inside this bucket, and save it for later, because I'm going to use it. So, how about we start using them? You know, because I'm going to use all 5 of these. So I'm just going to say cout, you know, I'll put a new line there just in case. This is an int. And you know what, I'll give myself a tab or 2. And obviously, now here's the thing. I can't just simply go and say plus, you know, example integer. It's not going to work. It's not going to work. There is a way to do this where you can turn an integer into a string and see, but it executed and it's just not working like that. So, there is a way to do that, but we're not going to do it in this video. I'm just going to go and say cout, and this time instead of putting a string, because we don't have to output a string, we can also just output a variable as well. And in that variable is an integer. So I can just do that, and now you'll notice it says this is an int 10. So this is an integer, tab over, so it did 2 tabs, and then example integer got printed next. So cout is not going to automatically make a new line. You have to make your new lines with that /n. So, and then, you know, same thing, cout, you know, /n, and we'll say this is a float. And then, you know, /tab. And same thing as well, cout. And we'll put in the example float. Okay? Example. So as long as I name these guys the exact same thing I named them up here, it will work. So it doesn't matter if you named it example float or just, you know, example 1 or E1 or Bananarama Ding Dong. It doesn't matter. As long as whatever you name it here, it's the same thing you name it here. As long as what you name it here is the same thing you name it here, it will work. Okay? So, but I recommend getting in a habit of naming things that will make sense, you know? It's much easier to remember player 1 plus player 2 equals player 3 than it does to remember lava plus stapler equals computer, okay? Name things that make sense. So we'll just do some more couts, you know, /n. I want you to get in a habit of remembering /n's and /tabs just to make things look pretty. You know, this is a string /tab /tab. And remember to always end things with semicolons. Cout, example string, and cout, you know, this is a char, and /tab, whoops, cout, example char, making sure I name those things correctly. And the example char is gonna, no, not the example char, the example bool is gonna be interesting when we look at it. This is, whoops, a bool, /tab, and cout, example bool. And then, just for the sake of it, /n/n. Whoops, I forgot a few /n's. /n. There we go, just so for some spacing. And then at the end of the day, I'm just going to keep a return 0. And that's basically the end of the program, and it will tell me that it returned with an end code of 0. So as long as I know it got there, I know we made it through the entire thing without hitting an error, theoretically. So there's going to be one interesting thing about this bool, so I'm going to want you to remember that when I hit execute. Oh, what did I hit? I have forgotten a semicolon. But you see, it does tell me, it will tell me that I forgot a semicolon. So, as I said, there are example bool. Because I said example cool, not example bool. Like I said, naming things is important. Name it the same thing and you won't have errors. So now you'll notice that there's an integer, 10. This is a float, 5.5. This is a string, hello world. This is a char, w. This is a bool, 1. Now that 1, remember where I said what was the machine language? What was the binary language? The ons and offs, the true and falses, were represented by what? 1 and 0. So when I said this was true, it visualizes that true by printing out a 1. Now, obviously, I might have made, you know, too many tabs here and in some of these guys. And I guess that float can go away. You know, just to make things a little bit more pretty and line up. You know, there we go. It looks perfectly lined up now. But yeah, so that's essentially everything. Now, I know this is a lot to take in with a lot of different types of things, like what's an integer, what's a float, what's a string, what's a char, what's a bool. But really all we did was we just did couts a bunch of times, and we just named some variables, okay? So this is all information that'll be very beneficial to you, you know, later on in all the other programs and all the other coding. So come back to this video, come back to this code. You know, hopefully you were adding some comments along the way, and even if there was more stuff you didn't know and wanted to remember, you know, hopefully you added more comments, like, you know, maybe you want to know that, you know, true equals 1, false equals 0 in output. Maybe you want to know something like that. So if there was anything interesting in this video that you wanted to put in, be sure to make a comment. Be sure to make a comment so that you know what is happening on each line of this code. Because that's the best sort of, you know, little helper I can think of then, is your own note-taking abilities. So, there we go. Your own programs that you're making step by step while watching these videos. So, thank you very much, and I'll see you guys in the next video, because this is it. This is the first assignment in C++. So save it. You can either copy and paste this into a Word document and send it that way, or you can save the file and either send me a link, or you can go and send it to, because you can save to a local file, you can just send that file through the online submission as well. So, however you want to send that to me, I probably recommend a Word document because it's easy to just copy and paste that. But we can just go in, save it, send it, and you're good to go. So, thank you very much. I'll see you in the next program.